Integration with Salesforce begins with a single technical requirement: obtaining an access token that permits programmatic access to protected API resources. Achieving this requires a strategy that varies depending on the client. Connecting a user-facing web application involves different security considerations than connecting a headless backend server or a low-power IoT device. These strategies are driven by the specific hardware and software capabilities available to each type of client. To identify the correct model, we evaluate three variables: whether a user is present to interact with the system, whether a web browser is available, and the extent of the device's input capabilities. By subtracting these capabilities from the client profile, we can logically derive which authentication flow is required for a specific environment. Salesforce provides a suite of discrete OAuth 2.0 flows, each designed to function within these specific system limitations. Integration architecture is most effective when the authentication flow is selected to match the physical and digital constraints of the client. Consider a standard web application where a person needs to access their Salesforce data. In this scenario, a user is present, a browser is available, and input is active. These conditions enable the authorization code flow. The browser redirects the user to log in directly with Salesforce. Once authenticated, Salesforce provides a code that the application exchanges for an access token. This preferred flow ensures the client application never handles or stores raw credentials. The architecture changes significantly if we remove the browser from the equation. Without a browser to facilitate a redirect, systems sometimes default to the username-password flow. Here, the client application must collect the user's credentials and pass them directly to the Salesforce API to request a token. This model forces raw credentials to pass through the application layer, which increases the risk of credential theft if the application or the transit path is compromised. Because of this exposure, Salesforce recommends against this flow unless you are integrating with a legacy system that cannot support modern redirection or token-based methods. While interactive login via a browser provides a secure baseline, stripping that browser away and continuing to use passwords creates a structural vulnerability. Different constraints apply when we move into the data center, where automated backend processes run without human supervision. For these headless integrations, there is no user, no browser, and no manual input. This requires a method for the system to prove its identity and gain access without a human present to type in a password. The client credentials flow addresses this by allowing the machine to authenticate using a static client ID and client secret. While this removes the user from the loop, it still relies on a static secret that must be managed and protected by the client. A more robust option for these server-to-server integrations is the JWT bearer flow. This flow replaces passwords with cryptographic assertions. The client creates a JSON web token containing its identity claims. The client signs this token using a local digital certificate, creating a mathematical proof of its identity. This signed assertion is sent to Salesforce, which verifies the signature and issues an access token. No passwords or static secrets are transmitted. This provides a layer of protection because the private key used for signing never leaves the client's secure environment. Even if the signed assertion is intercepted, the attacker cannot use it to discover the underlying private key. For automated backend environments, shifting from shared secrets to cryptographic assertions makes the JWT bearer flow a highly secure architectural choice. We also see unique constraints in physical hardware, such as smart TVs or kiosks located at the network edge. These devices usually have a user present, but lack a full browser and have very limited input capability. The device flow solves this by decoupling the logging process from the restricted hardware. The device displays a code, and the user completes the authentication on a separate, fully capable device like a smartphone. This allows the constrained hardware to receive a token without the user ever having to struggle with limited input. Beyond the initial connection, the architecture must also account for how access is maintained over long periods. Access tokens are designed to be short-lived. Once they expire, the application loses its connection to the API. The refresh token flow allows the system to maintain that connection. By using a refresh token, the client can request a new access token in the background, ensuring the integration continues to function without requiring the user to re-authenticate. Managing these hardware limitations and session lifetimes ensures that security does not come at the expense of a seamless integration. We can organize these flows into a single logical framework based on the constraints we've identified. The Salesforce OAuth 2.0 decision matrix provides a path to the correct flow by answering a few binary questions about the client environment. Standard web applications are directed toward the authorization code flow, while devices with limited input are routed toward the device flow. The matrix serves as a reminder to avoid the username-password branch unless it is strictly required by legacy constraints. When we look at the requirements for automated server-to-server communication, the path is clear. The JWT bearer flow is the recommended architecture for building secure, automated data pipelines that don't rely on human intervention. Salesforce OAuth 2.0 is a constraint-driven framework designed to provide a mathematically secure way to connect any physical or digital topology to your data.